Welcome to this lesson on virtualization basics, the foundation of cloud computing. Virtualization is one of the most important technologies that makes modern cloud computing possible. Understanding virtualization will help you grasp how cloud providers deliver services efficiently and cost-effectively. Let's dive in and explore this fundamental concept. So, what exactly is virtualization? Virtualization is a technology that creates virtual versions of physical computing resources, such as servers, storage, networks, and operating systems. Think of it as creating a software-based representation of hardware. The key benefit is that multiple virtual machines can run independently on a single physical server. This means one powerful computer can act as if it were many separate computers, each running its own operating system and applications completely isolated from each other. Virtualization matters for several important reasons. First, it provides cost efficiency by maximizing hardware utilization and reducing the number of physical servers needed. Second, it enables resource optimization, allowing CPU, memory, and storage to be allocated dynamically based on actual demand. Third, it offers isolation and security, where each virtual environment operates independently so that failures remain contained. And fourth, it enables rapid deployment, allowing new environments to be provisioned in minutes instead of days or weeks. These benefits make virtualization essential for modern IT infrastructure. At the heart of virtualization is a component called the hypervisor. The hypervisor is a software layer that creates and manages virtual machines by abstracting physical hardware resources. You can think of it as a bridge between physical hardware and virtual machines. The hypervisor is responsible for allocating resources like CPU, memory, and storage to each virtual machine and ensuring that these virtual machines remain isolated from each other. This isolation is critical for security and stability in virtualized environments. There are two main types of hypervisors. The first is called a Type 1 hypervisor, also known as a bare metal hypervisor. This type runs directly on physical hardware without needing a host operating system. Because it has direct access to hardware, Type 1 hypervisors provide maximum performance and efficiency. Common examples include VMware ESXi, Microsoft Hyper-V, Citrix Xen Server, and KVM. These are typically used in enterprise data centers and production cloud environments where performance is critical. The second type is called a Type 2 hypervisor, also known as a hosted hypervisor. Unlike Type 1, this type runs as software on top of an existing operating system. Type 2 hypervisors are ideal for development and testing environments or for running virtual machines on personal computers. Common examples include VMware Workstation, Oracle VirtualBox, and Parallels Desktop. While they may not offer the same level of performance as bare metal hypervisors, they are easier to set up and use for non-production purposes. A virtual machine consists of several key components. First is the virtual CPU, which represents allocated processing power from physical CPU cores. Second is virtual memory, which is dedicated RAM allocation for each VM instance. Third is virtual storage, provided through virtual disk files that emulate physical hard drives. And fourth is the virtual network, which includes simulated network interfaces for connectivity. Together, these components allow a virtual machine to function just like a physical computer, with its own operating system and applications. There are several important concepts in virtualization you should understand. Snapshots allow you to capture the state of a virtual machine at a specific point in time, making it easy to roll back if something goes wrong. Live migration enables you to move running virtual machines between physical hosts without any downtime, which is crucial for maintenance and load balancing. Templates are pre-configured VM images that allow for rapid deployment of new virtual machines with consistent configurations. These features make virtualization powerful and flexible. Virtualization is what makes cloud computing possible. It enables multi-tenancy, where multiple customers can share the same physical infrastructure while maintaining complete isolation. It provides elasticity, allowing resources to scale up or down automatically based on demand. It enables on-demand provisioning, giving users instant access to resources without waiting for physical hardware setup. And it supports the pay-per-use model, where billing is based on actual resource consumption rather than fixed capacity. Without virtualization, modern cloud computing as we know it would not exist. Virtualization has many practical use cases in real-world scenarios. Server consolidation allows organizations to reduce the number of physical servers by running multiple workloads on fewer machines, saving space, power, and cooling costs. Development and testing benefits from the ability to create isolated environments where developers can safely test code without impacting production systems. Disaster recovery is greatly simplified because entire systems can be backed up and restored quickly through snapshots and replication. These use cases demonstrate why virtualization has become a standard practice in modern IT infrastructure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.